Okay, hello, welcome to Spark Revise. We're going to be looking at the J277 OCR Computer Systems Paper 1. So this is for the new spec from 2022. Don't think we'll have any of the old spec ones on the channel because they're not really relevant anymore, but for the new spec papers we'll have all these uploaded on the channel. We'll also be running computer science revision live streams eventually, so if you go over to our community page and just vote on the little poll on there, we'll be able to start running some live streams as we get closer to GCSEs. So this is paper 1, so this is everything that's not your programming stuff. It's a non-calculator paper, so don't bring your calculator into the exam. Just a few bits of housekeeping. Remember, fill out your centre number and candidate number and then your first name and last name. It's 80 marks. You've got, I think, an hour and a half, so plenty of time. Roughly a mark a minute, which should be perfectly easy, and I find most people finish early on this paper anyway. So 16 pages, make sure you check till the end, and we are going to start. Another important thing, quality of extended response will be assessed in questions marked with an asterisk, so just look out for that, and that's when you're marked on your kind of how well you're writing, not just the content you're writing. So question 1, computers represent data in binary form. Tick one box in each row to identify the binary unit equivalent of each of the given file sizes. So we've got 4 different file sizes given, and we need to kind of identify what unit they convert to. Right, we know 8 bits is 1 byte. So that is just some background information. So 1000 byte equals 1 kilobyte. So 2 kilobytes would be 2000 bytes, so we're going to put a tick there. 2000 terabytes. So a terabyte is a very large number, so it's 1000 gigabytes. So what's the step up from terabytes? Petabytes. So we're going to tick 2 petabytes. I'm just skipping through these easy ones nice and quick. If you do need help with these, we'll hopefully have some videos out on the channel, and you can also check on the internet. 16 bits. So we know 8 bits is a byte, so 16 bits is going to be 2 bytes. And we've got 4 nibbles. So a nibble is 4 bits. Is a nibble. So 4 nibbles is going to be 8 bits. 4 bits. So 4 bits is 1 nibble. So we know that 4 nibbles is going to be 16 bits, which equals 2 bytes. So we can tick 2 bytes, and that will give you the full marks. Perfect. Right, on to the next question. Convert the denary number 221 into 8-bit binary. Show you're working. So for binary conversion, it's always good to draw out a binary conversion table. So we're just going to start with 128, 64, 32, 16, 8, 4, 2, 1. And then we can just draw a line under it, just like that. Perfect. So, does 128 go into 221? Yes, it does. Pop a 1 there. Then we're going to do 221 minus 128, which is 93. So 64 goes into 93, yep. That gives us 29 remaining. 29 does not go into 32, but sorry, yeah, 32 does not go into 29, but 16 does. So we've got 29 minus 16, going to be 3, 13. 8 goes into 13, put a 1. 13 minus 8 is 5, 1, 0. And we've got 1 left, 1. So your answer is 1, 0. Sorry, 1, 1, 0, 1, 1, 1, 0, 1. Perfect. That will give you full 2 marks. Convert the hexadecimal number 2f into denary. So I don't know how you've been told to do hex to denary conversions, but I split them into nibbles. So you've got 2f, you're going to make each one into a nibble. So if 2 is a 2 is going to be 8, 4, 2, 1. Just do some little binary conversion tables. And then again there, we'll do 8, 4, 2, 1. So 2 is just going to be that. F, if we remember, so hex runs up to 9, and then we've got A, B, C, D, E, F, so 10, 11, 12, 13, 14, 15. This is something I would always write out in the exam, a little kind of hex numbers to letters sort of conversion. So we know F is 15, so we're going to have 8 plus 4 plus 2 plus 1. So that's our binary. So I would always advise convert to binary, convert to nibbles. Then if we just, sorry, I'm writing really big because I haven't got much space here, so just erase that. We're going to then go, we've got our number, it's 00101111, and now we're just going to convert that to denary. So we've got 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. So it's going to be 32 plus 8 plus 4 plus 2 plus 1, which we know is 15. So it's 32 plus 15, which equals 47. And that will give you the full 2 marks. Convert the binary number 10110000 into hexadecimal. So once again, let's split it into nibbles. Let's split it down the middle like that. This is going to be 0. This is going to be 8, 4, 2, 1. 8 plus 2 plus 1 is 11. We remember we've got our 9, 10, 11, so A, B. So we know 11 is B. It's B0. That will give you the full 2 marks. Identify how many unique values can be represented by 4 bits. Yes, so for each bit, each bit can either be a 0 or a 1. You've got 2 possible combinations, and you've got 4 bits. So all we do is 2 to the power of 4, and that is 16. Very simple. That will give you your mark. Perfect. Perform a binary shift of 3 places right on the binary number 10001110. So all we need to do is move every number right. So we've got our number 10001110. We're going to move each bit right by 3, starting with this one. It's going to go 1, 2, 3. It's there, and then we can just build this so it's 0, 0, 0. That one goes there, and we pack with zeros on the left hand side, giving you 0, 0, 0, 1, 0, 0, 0, 1 for your mark. Next up, question 2. So we are going to be looking at CPU architecture for this question. So this should be nice and simple once more. So part 1, column 1. All we need to do is match the component to the definition. And this is a nice 4 marks. So something stores the address of the next instruction to be fetched from memory. It increments during the fetch decode execute cycle. If you can remember this, this is the program counter, or PC, because it's what holds your next instruction in RAM, and it increments every time to point to the next instruction. So very simply, that's the definition. You need to know that. Basically, great standard definition to remember for PC. So if you haven't got that on a flashcard, whack that on a flashcard right now. So the control unit fact, actually, I'm going to pass by this one, go on to the next one, go to the easy ones, which is just writing a simple label. Stores the address of the data to be fetched or the address where the data is to be stored. So we're looking at addresses. This is the real address of data, address. So we already know from the word address, this is the MAR. It's the memory address register. It holds the memory addresses that are being read or written. Performs mathematical calculations and logical operations. So as soon as we hear maths, we hear logic. We go ALU. And again, this is some really good flashcards you can make from these here. So the ALU performs mathematical calculations and logical operations such as and, or, and not. Then, going back to the CU. So the control unit, what does it do? Your main definition you need is direct flow of data through CPU. And so you only need one comment, but for another mark, well, for the sake of getting it right, decodes instructions and runs FDE cycle. That gets you your mark. Then you get your full 4 marks, but you do only need one of those things to get your mark. Again, put these on flashcards if you haven't already. There should be a video on the fetch, decode, execute cycle out on the channel shortly. Moving on to question 3. So, right, question 3A. We're looking at networks now. Again, there should be some network videos out on the channel, so if you go and have a look. I'll also link down in the description some good revision resources for computer science, some websites, some YouTube channels to go and have a check out as well. And I think the most important thing when you're doing revision is to shop around. Make sure you're not just getting all your stuff from one place. So yeah, go to the description, check out that, please. So, a library has a local area network. This is when I'd start probably getting my highlighter out, to be honest. Wired and wireless devices. It runs very slowly. Explain why number of devices can affect the performance of the network. And it's 3 marks. It's our first 3 marker. So, let's think about reasons why our performance would be affected. So all we need to make is 3 points, and I would say at GCSE level, bullet points are acceptable. So just go straight for bullet points. So I would say I would say there's 3 main points you can make. Slower. Slower transmission speeds, because more data is being sent at the same time. I would say higher latency, which means that devices are waiting longer to transmit. And I would say higher rate of collisions. So more packets have to be retransmitted. I would also say that you could say, let's see what the mark scheme is saying. Bandwidth being split between devices, there's less bandwidth for each device. Maximum bandwidth might be used, so then devices cannot transmit, and the switch or router or central device may have to handle more requests, so may run slower. But these are your main things to talk about. In a 3 marker is slower transmission speeds, you've got more data being transmitted at once, which is basically talking about bandwidth. Higher latency, so devices are waiting longer to transmit, and a higher rate of collisions as more packets have to be retransmitted, which causes more packets to have to be retransmitted. Also, guys, if you want these papers, so this paper and the mark scheme are linked down in the description below. So go and check out the mark scheme as well. So identify one other factor that can affect the performance of the network. So there's so many things you could list for this. I would always go to this is hard. There's so many things you could say. I would say my one for this would be transmission medium. Whether you're wired or wireless, because that will make a big difference. But you could also say bandwidth, interference, error rate, distance between nodes, topology or physical layout, and wireless repeaters. So honestly, say anything and it'll get you the mark. You could literally say bandwidth and it'll get you the mark. Nice and simple, 4 marks. So users can access websites from library computers. This is lovely. 7 marks, fill in the blanks. Perfect. So, a website is hosted on a... Well, what on here is a website hosted on? Correct, web server. And just cross that one out. The computers that access the websites are called, clients, because we talk about client server. The user enters the what do they enter? Well, it's not spelled out how we talk about it here, but you're entering a URL or uniform resource locator. So we're going to add that in URL into the web browser. The web browser sends a request to the domain name server, DNS. So remember about websites. Client enters the URL into the web browser. The web browser then uses that URL, sends a request to the domain name server. This gets the IP address of the website, which can then be used to access the website. And doesn't go into that detail here. This is just about requesting the IP. If the IP address is found, it is returned. A request is then sent to this IP address. IPv4 addresses are made of 4 groups of digits. Each group can then be the denary values, could be between the denary values of 0 and 255. Because if you think about binary, that's what they're between. The groups of digits are separated by, and this one catches a lot of people out because you can't picture it for some reason when you're in the exam. And I would have got this wrong, I think. I would have for some reason said a colon. That's a MAC address. IP addresses use, where is it? A full stop. So we put full stop. And Bosch, 7 marks. Perfect. Sorry, I take it back. MAC addresses do not use colons, they use hyphens. So that's my bad. So part C. The wired connection is an Ethernet connection. Ethernet is considered a standard. Explain why Ethernet is standard. So what is a standard for a start? It's something that ensures that devices from different manufacturers are allowed to communicate, and Ethernet is the most popular of them. So that's why this question's about it. So it just means that it's the same for everybody, no matter whether you're on a Mac or you're on a Windows computer or any kind of device, not just computers. I think we sometimes just think, but any kind of device means that they can communicate with each other, because without that they just wouldn't be able to. They'd be talking different languages and you wouldn't be able to understand what was going on. So why is Ethernet a standard? So I've kind of touched on it there. It's, oh hang on, we want black. Again, do bullet points. Used by all manufacturers, mostly all of them, allows and it allows compatibility with other devices. You could also say, and that would get you 2 marks, but you could also say it's a high bandwidth, inbuilt security, proven and reliable connection, has low cost for purchase, installation or maintenance compared to some other wired connections. But this is all you really need to say, is defining a standard. If you want to go into more detail about Ethernet, you can, but I wouldn't have known much about Ethernet other than it's a standard. So this would get you your 2 marks. So the network has several routers. Identify 3 tasks carried out by a router. So a router is something that connects networks. It directs packets between devices on the network, and it uses a routing table to determine the best path for data to cross a network between devices. So we're just looking at tasks carried out by router. Again, kind of touched on some there. So like we said, let's go for the basic 3. Receive packets, forward or transmit packets, and number 3 we'll say assign IP addresses. We could also say most efficient path. So it finds the most efficient path between 2 nodes, or converts it can convert between protocols. So the library does not use encryption when data is transmitted through the network. Give 2 reasons why the library should use encryption. So what is encryption? Encryption scrambles data so only authorized users can read it. You've got asymmetric and symmetric encryption, but I don't think this is talking about that. So it's just asking, why should the data be protected, basically. So 2 reasons. Let's have a think. So I would say, so data cannot be understood if intercepted. Protect. So that would get you 2 marks. So data can't be understood if intercepted, it'd be meaningless. So only authorized users can read it, so it protects personal and confidential data. You could also say, another 3rd point would be follows or adheres to the data Protection Act, which you cover in the ethics section. So 2 marks. Perfect. Protocols are used to transmit data through the network and over the internet. Identify one protocol that can be used to perform each of the following tasks. So sending an email, this is kind of thing you just need to know. There's not really any particular wiggle room. So emails is Simple Mail Transfer Protocol, or SMTP. Again, mail's in the name, it's going to be to do with emails. Accessing website. So accessing a website is HTTP, or Hypertext Transfer Protocol. When you've got this word securely, it's really important that you add that S on the end. So we've got HTTPS, Hypertext Transfer Protocol. Secure, bosh, 2 marks. There's no wiggle room for them. It's got to be those 2. So we're coming on to our first long answer question. It's 8 marks. We're going to be looking at social networking websites use AI to monitor posts from users. Discuss the positive impact and negative uses of AI by social networking sites, including legal, ethical, and privacy issues. First thing I want to say, I'm going to have a crack at this by just giving you the main points you need to make. I'm not going to actually write it out, because I think it requires a bit more planning than that. I don't want to bore you. But 2 things. If you want me to mark yours, if you DM us on Instagram, Instagram link in the bio, I'll happily mark your 9 markers, 12 markers within the day, get your feedback for you, okay? So if you want me to mark this question or any of the other 9 markers in any of the other practice papers for any exam board, just let me know. Also, always chuck into ChatGPT, take a photo of it, upload it to ChatGPT, that will mark it perfectly for you if you give it a copy of the mark scheme as well. So yeah, either or. So what kind of stuff do we need to talk about? So let's divide it. I'd always do a plan. So I'm going to list legal issues first. Let's look at legal issues. Nice big underline. So we're talking about AI for social networking. What could be some legal issues? I'm thinking copyright, design, patent, patent. So when we're saying issues, we're not necessarily thinking of negative. So I'm saying this can be used. We can use AI to recognize copyright. So we're saying it's a good thing. So it's going to put a little tick there for good. We've got a negative, DPA. We've got to make sure that AI handles data in accordance. So you can talk a bit more about DPA. So are we storing it properly? Are we using it properly? Is it getting shared anywhere? You know, how is this data being used? We could also have checking legality. This is a good thing. Going through photos, going through documents, making sure they're all legal, can handle a lot in one go. It's very powerful, whereas it would take a human a long time to check all of that, and that's the kind of comparisons you need to be making. And we've got another kind of neutral. I'm just going to put it as a neutral. We've got user agrees. 2 T's and C's expected. So the user would agree to use the AI anyway, so there's not really any legal issues. Let's look at ethical. Maybe I'll do a video on answering long answer questions below, guys. So ethical issues. AI might be wrong, so it might incorrectly block posts or users. That's a negative. We've got positive, limit. Limit plagiarism by, we can use these AI plagiarism checkers now, which scan through all your documents and make sure it's not been plagiarised from anywhere else on the web, so that's really useful. And it's ethical, it's to do with people and their lives. And on the similar topic, prevent harmful content being published. So that's another good reason. Neutral thing is that website must tell the users about the AI and what it's doing. Users may feel safer, positive. Knowing that everything is being checked and approved. It's like privacy issues. Got a negative. It's always good to kind of put yourself in a user's shoes. The feeling of being watched. User might feel like they're constantly being kind of observed the whole time. That might be a negative feeling. We've got another negative, like terms and conditions. You might feel like you're signing your life away. And we've got a positive, which I think is a really important point to make. Also, to add to ethical, we could say about another negative would be people losing jobs. People might be losing their jobs to be replaced by an AI. Computer versus person for privacy issues, saying that I probably prefer a computer to look through all my photos than a real person, because at least it's privacy. You've got the security of knowing that it is just a computer looking at your photos. So, moving on. Number 5. Cybersecurity. So, 5A. Identify 2 methods of physical security the company could use to protect their computer systems. So these are so simple. This is barely computer science. Physical security, I'm just going to list them. We've got alarms, locks, keycard entry. Physical security being things you can touch. People, guards, CCTV, passcode, biometrics. All are appropriate answers. But with these two, the key thing is you put for entry to room. So, yeah, all of them would give you your 2 marks. Identify and describe 2 software-based security methods a company can use to protect their computer systems and their data. So, software-based this time, this is things you can't touch, obviously. Software security protects against hacking, malware, and unauthorized access. And there's probably there is a lot of different things you could have here. So, I'm going to just... There is a lot. I'm going to list the things you could have, and then I'll go into more detail about them. So we've got, you could have anti-malware. So this is just any software that prevents malware, scans your computer, deletes viruses, stops downloading of viruses, anything that's kind of generalized on your computer. We've got firewalls. These monitor the ingoing and outgoing traffic, compares traffic to a criteria, and then blocks any unauthorized traffic, and we call it package dropping when it cuts a package because it's unauthorized. We've got encryption, which we touched on earlier. I know which two I'd pick. We've got user access levels. So having, your manager gets certain access, but you get less access because you're not as senior as them. We've got antivirus, similar to anti-malware. Stops any viruses, scans that for them, quarantines and deletes them, stops the downloading of them. We've got anti-spyware. We've got passwords / biometrics, because it's still software, isn't it? And we've got two-step verification. But I think the easiest two to explain is just nice and simple firewall, and I'd say antivirus or anti-malware. And I'd put, for firewall, I just put, or you could put encryption, to be fair, that'd be another good one. There we go. We've got antivirus. So that scans for malware or viruses. Alerts user. Deletes. There we go. And always use bullet points. So much easier. So that would get you 6 marks. But you could elaborate about any of them. And again, just if you want to know about any more of them, head over to the mark scheme and it'll give you a load of information about them. So we're on our, we're very near in the end now. This is nice, easy. This is a great, easy tick box one. So we've got about legislation. So you just need to know your legislation with this one. A company transmits personal, I'm going to whip up my highlighter, personal data to another company without permission. What act are they, or what act are they breaking? And we talk about data, that's the key thing here. So straight in, we know it's the Data Protection Act. Data Protection Act protects personal data. A school accidentally publishes their students' addresses on the school website. Again, it's addresses, it's data, it's the Data Protection Act. The interface of a piece of software is replicated software. So, what are we looking at? For starters, software, computers. Is it the Computer Misuse Act? No, because it's not about the misuse of a computer. It's not about a computer being used for crime. It is a crime. It is the Copyright Designs and Patents Act, something that a company has produced, or anything you produce automatically is assigned copyright to yourself. It protects their intellectual property, and because the automatic copyright has been, compromised by a rival company, it's the Copyright Designs and Patents Act. A user leaves a computer logged on, another person leaves them a message. That is, I don't know what happened with highlighting there. That is the Computer Misuse Act. Very much so. It's the user's in the wrong for leaving the computer unlocked, and that could possibly pose kind of, if they were a teacher, it could be, and they had all student details on the computer, that would be a data protection breach. But we're really focusing on the person who is leaving the message. They are unauthorized to go on that computer, and yeah, going on your mate's computer at school can be a breach of the Computer Misuse Act. And for the final one, a student guesses their teacher's password and accesses their computer account. So it's the teacher's password and they're accessing, this is the key bit, accessing their computer. It's the Computer Misuse Act. They're in the wrong. You can't use someone else's computer. So it's 5 marks. Nice and simple. So, we've got question 6. So, computers can't store analog signals. So, analog is like the real world signal. It's the sound wave you see in physics. So, they have to digitize these analog sound waves. The process is called sampling, and it converts continuous sound waves into discrete digital values. So if you know about discrete and continuous can be anything, whereas discrete, it has to be a certain value. So that is what the process of sampling is. It takes a sample every second or whatever and works out the wave height at that point. So there we go, I've already given you a point. Sound wave is sampled. Sound wave is sampled. The wave height is measured. At regular intervals. Each is stored as a binary number. And that's all you need to know, really. Get you 3 marks. So 6A. So we are looking at some file size changes. So different aspects of audio affect file size and accuracy. So if you're changing the duration from 10 minutes to 20 minutes, what is going to happen? Your file size is going to increase. You've got double the amount of data to store, so your file size isn't going to decrease. There's no change to your accuracy, and there's no change to your accuracy because you're just changing the duration of the file. It's just simply like, it's like if you just double the amount of pages in a book. It doesn't suddenly become less accurate, it just becomes bigger. So the sample rate changes from 44 kilohertz to 8 kilohertz. So that means we're going from 44,000 samples per second to 8,000 samples per second. So your file size is not going to increase, it's going to decrease because we're doing less samples. Accuracy is going to decrease as well because you're just taking less samples. There's more change that could happen that we're missing out on. So bit depth changes from 8 bits to 16 bits. So when we're talking about audio bit depth, we're talking about the number of possible amplitude values we can record for each audio sample. So the higher the bit depth, the more values per sample captured to recreate the original audio. So basically, the bigger the bit depth, the more closer we can get it to the original audio. But it's going to mean the file size increases massively, but the accuracy will increase. So that will get you your 3 marks. I'd say that's quite a hard one. B. So, BI. We're looking at ASCII character sets. So ASCII is the American Standard Code for Information Exchange. That's a good thing just to know. It basically assigns numbers to each character. And we've got extended ASCII, which covers has 8 bits, and normal standard ASCII has 7 bits, so 1 to 8 characters. What have we got to do? Identify the character that will be represented by the ASCII denary code 84. So simply, we know it's an alphabet: M, N, O, P, Q. What comes after Q? A, B, C, D, F, G, H, I, Q, R, S. Oh, we've got red. So what comes after Q? Q, R, S, T. So R is going to be 82. S is going to be 83. T is going to be 84. Very simply, T. Identify a second character set. I wonder whether this will allow extended ASCII. Probably not. The only thing you're taught for this course is Unicode. So always put Unicode. If you do know another character set, feel free to put it. The mark scheme accepts any other valid character set, but the one they're expecting is Unicode. Perfect. A student takes a photograph of their science experiment. The image file includes metadata. identify 3 pieces of metadata that is often stored with an image. So metadata is extra information stored with a file, in this case image file, which helps with identification and organization. So the kind of things, there's like hundreds of things you can put for this. Image dimensions. So height, width, date, bit, depth, so it's to do with color storage. You can also have geolocation, file size, / type, compression type if it's being compressed, and author. Any one of them would get you a mark. So the student compresses all their documents before emailing them to the teacher. Give 2 benefits of compressing the data before it is emailed. So compression reduces your file size, aiming to keep quality as high as possible. You've got lossless compression, which keeps all data, and lossy compression, which removes some data. So we're just looking at why we're using compression in general. It reduces the file size. Really simple, straight off the bat. File size reduced. Second reason, faster to upload / transmit. There we go. That's your 2 marks. But you could also say less bandwidth, less data to send, requires less storage space, prevents you exceeding your email storage capacity. There's a lot of things you could say other than what I've said, but you know, that's all you need to say. That's your 2 simple reasons. Why might lossy compression not be useful? So we know lossy compression involves permanently removing data to reduce the file size. Things like text files, program code, and certain images need exact accuracy. You can't remove part of a text file permanently because you wouldn't be able to read it. Whereas with a sound file, you can remove some of the sound file, e.g. the top and the bottom of the waves, and you can still hear it exactly the same. Same with images. You can decrease the amount of pixels and still view the image. Whereas if you start removing words or letters from a text file, you really cannot read it. There's no way of removing anything permanently without making the file unreadable. So, key issues with lossy compression: data permanently lost forever. Text files cannot be lossy or loosey, apparently, compressed. So that's the reason for text files. They've also possibly got image files as well. Teacher requires high. I think this is the point the mark scheme gives, which is I'm a little bit dubious about, because kind of the spec teaches that lossy, even though for images to be compressed lossy, you shouldn't actually notice the difference, and that is really true. So in the naked eye on a normal computer screen, you shouldn't notice the image. So I kind of don't agree with that last point, but the mark scheme likes it. But I think the most important thing is that it says, why can't they compress all of them? You're saying there might be some text files. Text files can't be compressed with lossy because data would be lost forever, which would compromise the data integrity. Simple. Number 7. Difference between RAM and ROM. So, RAM is random access memory, ROM is read-only memory. We've got, I'd say, 2 main differences. So we've got RAM. We've got 2 main differences. So I'd say RAM equals volatile, ROM equals non-volatile. So volatile meaning loses data when the power is turned off. ROM doesn't, it stores your bootstrap boot up. You can't lose that data. RAM, it's just your recently used programs data, so it loses data when you power off. That would get you marked, but you could also say RAM is, this is very, right, it is RAM is read and write. ROM is read only. You can't write to it. And that would get your mark. 2 examples of data that the smart television could store in RAM. Well, we know RAM stores temporary, is the temporary data storage for whilst the TV is running. So it could be currently running apps. It also could be the operating system that's currently running. It could be data being downloaded. That would all get you marks. So part B, so why does a television need secondary storage with an example? So secondary storage is your big storage, so you're talking SSDs, flash drives, pen sticks, floppy disks, magnetic storage, HDDs, all that stuff that stores large quantities of data. So think your normal files, images, all that stuff. It might be built into the computer, it might be external, but we're not talking about your RAM, which stores your, and ROM, which are your primary storage. So appropriate type of secondary storage. Oh no, that's the next question, sorry. State why it needs secondary storage. It's non-volatile, so it's not data, not lost when you turn your computer off. So that's your reason. Stores data when turned off, e.g. operating system or downloads, settings, preferences. That's your 2 marks. And finally, final question of the paper. Identify one appropriate type of secondary storage for the smart television. So we've obviously got optical, which we're not going to talk about. We're going to talk about solid state and hard and magnetic. So magnetic includes tape, HDDs. Solid state includes your flash, your SSDs. What one do we want? And you can pick either of them. You just can't say hard disk drive. So you could say, so I would say solid state. Justification, large capacity. Lower power. Lower power consumption. No moving parts. Longer lifetime. Quick. Compact. Quiet. No moving parts. Links to that. That's kind of your options for solid state. If you wanted to pick magnetic, you could say even larger capacity. Television's unlikely to be moved, so portability doesn't matter. It's cheaper, so the cost of the TV will be cheaper to manufacture. It's relatively small and it's relatively reliable. So really you can argue similar points for both of them. The most important thing is to explain large capacity, therefore lower power consumption, therefore, and you get your 4 marks. So that comes to the end of the question paper. So I hope you enjoyed that. Please, please, please drop us a subscribe. We're really starting out. We're going to have loads of good videos up for computer science, maths and science subjects. We got a selection of past papers we're going to be going through, plus loads of explanation videos for the full spec, and we're going to be bringing out our website soon with loads and loads of data. But please drop us a subscription, hit that bell, and follow us on Instagram. Thank you, and have a good day.